Hello class, today I'm going to solve one of the tutorial questions for pressure variation when we have rigid body motion. I already solved question 2 during the lecture, so this time we are going to solve question 3. So U2 shown below contains Mercury and rotates about off-center axis AA. So we have an axis AA there, which is off-center, and this U2 manometer rotates about that AA axis. At rest, the depth of Mercury is in each leg is 150 millimeter, which is shown in at rest figure. Find angular velocity or omega for which the difference in the height h for the left side and right side between the legs is 75 millimeter. The rest is given. So the position of AA axis is given. D is 220 and E is 90 millimeter. Okay, let's go back. So this is our manometer. The first one at rest, both legs, they have 150 millimeter mercury inside. When it is rotating off center, so because it's off center, we expect to have more liquid on the longer the leg away from the AA axis or rotating axis. And the question says find this omega or angular velocity. Remember from the equations we extracted for the angular motion, we found that dz over dr is going to be r omega squared divided by g. And we integrated this formula and we got z equal omega squared r squared divided by 2g plus constant. So we need to use this formula to find omega. If you remember from the lecture session, the first step is we need to take care of this constant. We need to find that constant. Otherwise, we have too many unknowns there. For the sample question we solved during the lecture, we considered the surface of the liquid as one of the points we have all the information we needed. And so the pressure was 0 and the height was given, so we easily found this constant number. But this time we don't have this information, but we have the information for the left leg and right leg. Okay, so how I'm going to get rid of this constant? I'm going to write the formula for left leg and right leg here and here. Let's see. For the left leg, let's call it Z1 is going to be omega square. R is going to be D square divided by 2G plus constant. Let's write for point number 2. So let's call this Z2. Same omega square. The radius is going to be E, which is this. So E square divided by 2G plus constant number. Okay, Do I have Z1 or Z2? No. But I have the height difference between those two, which is h. Okay, let's use that. So I'm going to subtract these two and let's get, so Z1 minus Z2 is going to be h equal, let's factor omega squared divided by 2g t squared minus e squared, and constant number cancel each other out. Okay, now if I check this formula, I have all the information I needed to solve this h. I have h omega, so omega is going to be square root of 2gh divided by d square minus e square. So I have all those values. 2 times 9.81 times h is given 75 millimeters, so 0.075 divided by 0.22 square minus 90 millimeter. Therefore, W is going to be 6.04 radian per second. So it's all about finding equation and having a strategy to get rid of constant number or finding the value of that constant number. For the previous examples, we usually had a point with all the information we put inside this formula, and we get the only unknown was constant, and then we start solving that. For this case, we hadn't all the information we needed for 1 point, but we had enough information for 2 points. So I subtracted those 2 points to get rid of constant number, which was the same for both sides. Thank you very much.